Hello class 10. In this video we're going to see Thales theorem, which is also known as basic proportionality theorem, and I'm going to show you how to prove this. This theorem says that in a triangle, if a line is drawn parallel to one of its sides, so let's draw a line here parallel to this side BC, and this line is intersecting this side AB at D and AC at E. Then what the theorem says is AD by DB will be equal to AE by EC of the other side, AE by EC. This ratio and this ratio are equal. Given. Now we have a triangle here and a line DE parallel to BC, so we're going to write a triangle ABC and a line DE drawn parallel to BC, intersecting this line is intersecting AB at D, intersecting AB at D and AC at E, respectively. Now we have to prove that AD by DB is equal to AE by EC. AD by DB is equal to AE by EC. Now with this simple diagram figure, we cannot prove this. So in order to be able to prove this, we are going to make a construction here. Going to join BE, CD, BE and CD are joined, and we are going to draw a perpendicular here, EF. Let's call this EF. This line EF is a perpendicular drawn on AB, and this side also from this point D we're going to draw another perpendicular line upon AC. EF perpendicular to AB and DG perpendicular to AC are drawn. From this EF is drawn from E on AB, from E on AB, and this DG is drawn from D on AC and from D on AC respectively. Also BE and CD are joined. BE and CD are joined. Now let's prove this. We know that area of a triangle is half into base into height, perpendicular. And one thing you have to know here is, in a triangle, when we try to find the area, any sides can be taken as base. Now this can be taken as base, or this left side can be taken as base, or this one can be taken as base. So let's say this is PQR. Now if we are to take QR as base, then perpendicular is to be like this. This is going to be our perpendicular height. And if BQ is going to be taken as base, this BQ, this PQ, then this will be our height perpendicular, this one. And if we have to take PR as base, then this perpendicular must be like this, the height must be like this. Now, as a first step, we are going to consider this triangle ADE, this triangle, and we are going to take AD as base. So here we are going to consider this ADE, and we're going to take this AD as base. So if we take AD as base, then EF is our height perpendicular. So now we're going to write area of triangle ADE is equal to half into base. Half into base, we're going to take AD as base, AD into height. Since we're taking AD as base, like I said, EF is the height. EF, let's call it 1. And now next is, we will take this triangle now, this DBE. Now area of triangle DBE, area of triangle DBE is equal to half into, now DBE is this triangle. Now here in this case, since we're going to take this DB as base, this EF must be our height perpendicular. Now to understand this, supposing we have a triangle like this. Now this is our triangle. Now we want to make this one as base. Then if this is to be considered as base, then height perpendicular we have to draw outside like this. So this is our perpendicular, this is our height. So here, now since we are taking DB as base, our height is EF. So half into DB into EF, half into DB into EF. Okay, so let's call this 2. Now let's divide this 2 equation, dividing equation 1 by equation 2. Left and left we will divide area of triangle ADE by area of triangle DBE is equal to, right and right we will divide, half into AD into EF, half into DB into EF. Now here we can cut this half EF. Now what we got here is area of this ADE by area of triangle DBE is equal to AD by DB. AD by DB. Let's call this equation 3. Now again, to get the left hand side expression, we are going back to triangle ADE. Again, we're going back to triangle ADE. Now this time we are going to take AE as base. Now this time, if we take AE as base, then our height is going to be DG. So area of triangle ADE again is equal to half into base is AE into height is DG. Again we're taking AE as base, so height is DG. And the next triangle that we're going to consider is this triangle DEC, this triangle DEC. Now in this triangle we're going to take EC as base, so since EC is going to be the base, DG is going to be our height. So area of triangle DEC is equal to half into base EC into height is DG. This is the figure. We're taking EC as base, and so DG is the height. Okay, let's call this 4 and this one 5. Now we are going to divide 4 by 5, dividing equation 4 by 5, left side and left side. Area of triangle ADE by area of triangle DEC is equal to right and right, half into AE into DG, half into EC into DG, half cut, DG cut. So we get here area of triangle ADE by area of triangle DEC equal to AE by EC. Now let's call it 6. Now this equation 6 and equation 3, if we compare these two equations, this is equation 3 here and equation 6 here. Now we have area of triangle ADE, we have area of triangle ADE, and we're going to see whether this area of triangle DB and area of triangle DEC are equal or not. Now let us try to recall what you learned in class 9 about triangles between the same parallels and having a common base. Now these are two parallel lines. Now let's draw a triangle here. Let's call it ABC, this triangle, and then I'm going to draw another triangle here. Let's call it DBC. Now these two triangles, that is triangle ABC and triangle DBC, they have a common base here, and the common base is BC. And these two triangles are again between the same parallels. These two triangles lie between the same parallels. So what you learn in class 9 is that in these conditions the two triangles have equal area. The two triangles are equal in area. So in our figure, in this theorem, we have two triangles here, triangle DBE and triangle DEC. Now these two triangles have a common base, which is DE, and they lie between these two parallel lines. So you can see it in this way. Okay, this is the common base, and this is one of the triangle, and this is the another triangle. Now these two lines are parallel. Now since these two triangles have a common base and they lie between the same parallels, the area of these two triangles are equal. So what we're going to write here is since triangle DBE and triangle DEC are on the same base, DE, and lie between the same parallels DE and BC. Therefore, area of triangle DBE is equal to area of triangle DEC. Now these two are equal, so this equation 6 we can write. Therefore equation 6 can be written as this equation 6. Now in place of this DEC we can write DBE. So area of triangle ADE by area of triangle DEC. In place of DEC I'm going to write DBE equal to, right hand side will be AE by EC. Let's call this 7. Now finally we will compare this equation 7 and equation 3. Equation 7 and equation 3. Now this is equation 7 and this was our equation 3 here. Now here what we can see is that the left hand side expressions are equal. These two equations now have equal left hand side expression. So we can finally say that the two right hand side expression will be also equal. So we can say that AD by DB is equal to AE by EC. So I'm going to write here from 3 and 7 we get AD by DB is equal to AE by EC. Hence proof.